Hello and welcome. Thank you so much for lasting until the Sunday afternoon period. You're going to love what you're going to hear today. Welcome to PyCon 2017, ending 3 sessions, the first one of which is going to be Piecing It Together, a Beginner's Guide to Application Configuration with Mary Nagle. And we're very excited to have her here today. I do want to let you know that we're going to have a 10-minute break after the talk. You'll have plenty of time to get to your next talk or to stay here, take a break and come back. So no rushing out before she's done. It's going to be a very good talk. The other thing is, please, please, please turn off your electronics or at least make them quiet. Thanks so much for coming here. Let's give Mary a big hand.
Hi everyone, as you said, I'm Mary. I'm a software engineer at Warby Parker, and this is my talk, Piecing It Together, a Beginner's Guide to Application Configuration. So I'm going to start with a quick show of hands. Raise your hand if you've ever been given the advice that the best way to learn to code is just by doing it. All right. Somewhat related follow-up. Raise your hand if you ever encountered technical documentation and you had no idea what it was trying to say. All right, so this clearly is resonating with some of you. This was certainly the case for me. I'm self-taught, so when I first started coding, I had no technical background. And when I would go to practice, this would lead to a lot of frustration, trying to claw my way through documentation and spending 0 time coding. So for example, this paragraph is from the SQLite documentation. Like, what is this even trying to say? I had no idea what any of this meant as a beginner. And you encounter this kind of documentation. It's like, how are you supposed to make a decision about your application when you can't even understand what's written about it? So the point I'm trying to make here is that documentation is a big old pain in the butt. And it's okay to feel that way. There's a lot of good documentation out there and a lot of bad documentation. But either way, you have to fight your way through it. But it does get easier the more you know. And I found that the more technical concepts or technical terms that you're at least familiar with, the easier this gets. So that's what we're going to try to cover in this talk. I'm going to go over some technical terms and concepts that come up a lot in application development that will help you, and knowing these will help you better understand documentation, but also form better Google queries, and I'll show you what I mean by that. So if you want to practice building a website, you might Google something like make a website. And this is what you get. You get a bunch of ads for Squarespace-like tools. There's a tutorial for how to build an HTML web page, but none of the really meaty technical stuff you're after. And even if you refine it a little bit, the tutorials that come up, you're like not sure if they're reliable. It doesn't really tell you exactly what's going on. And part of the reason you're getting this information back is because you don't know the tech terms to search for. So that is to say, there's a ton of information out there related to the topic of web development. And finding the helpful information and sifting through it is hard. Googling is hard. And we're going to get specific about how to build an application in this talk. But the underlying goal is to make this process easier for you and set you up with the knowledge you need to help yourself as you go through the steps of making a web app. And again, with Googling, getting specific helps. So for example, if I were to do this, I would search for build and deploy a Python website using Flask and SQLite. And here you just get 4 full tutorials that tell you how to do it with these specific technologies. But even so, none of these tutorials explain that there are other options out there or why you might choose one over the other. And while it's frustrating, it's also understandable because who has time for that? The person writing the tutorial doesn't have time to list out every single technology, and you don't have time as the person learning to sift through all that. And unfortunately, this talk is no exception. I have about 27 minutes left to teach you how to build a website in Python using as little technical jargon as possible. And so what instead I'm going to try to do is arm you with the technical vocabulary you need that will help you get through documentation and find the information that will help you. And to do that, I'm going to give you a ground-up explanation of what to do when you want to build a web app in Python. So I'll list the key benefits of the more popular options for each step, and realizing that there are a lot of beginners out there, I'll also provide a sample recipe of what technologies you should use when you build an application. So this is what we're going to cover. The first 4 are kind of key components of building an application, and then we're going to finish off with how to tie them together and how to connect your app to the web. And you can think of what we go through here as a recipe, because with cooking you can use different ingredients, but you'll still end up with something edible. It'll just taste different. And similar with building a website, you can use different technologies, and it might function a little differently, but it'll still work. And either way, the more you learn, the more advanced you get, the better you get at telling what fits what situations and what works well together. So to start, we have your operating system, and we're going to build on this as we go. So the thing about these first components that I mentioned is that they all require some sort of installation, or at least rely on packages that require installation. And package installation can be tricky as a beginner because you want to make the best choice for your application, but in order to do this, you have to sift through all that technical documentation to try to figure that out. So what I'm going to do is walk you through some common terms often found in package documentation. And the fun part is that once you know these terms, you can be free to ignore them completely and just focus on what the package actually does. So for those of you unsure what I mean when I'm saying package, let me briefly explain. So Python and the Python ecosystem as a whole are full of packages. Most of them are just kind of an extension of the language, but some of them are also very useful tools. So for example, this crazy wacky coloring here is because I'm using IPython. I don't have like some weird formatting on my terminal. I'm just using IPython, which is a tool that's basically a Python console on steroids. And in IPython, I'm using the package PyTZ, which you can use to change the time zone on datetime objects. So here I'll import it, here's the date time, and then here's where it's converted to UTC. So in order to use PyTZ or IPython, you have to install them. And you can do that by finding their installation instructions on their page in the Python package index. And here, again, you hit the tech documentation problem. So this is actually from the installation instructions on the PyTZ page. So raise your hand if any of these terms are unfamiliar to you or you don't know what this is saying. Right? Yeah, so before I made this talk, I had zero idea what any of these words meant. And they create this obstacle for you because you're reading through and you're like, I don't know if this word's important. I don't know if this is going to completely mess me up and break everything if I don't know what this word means and I ignore it. So I'm going to try to remove that obstacle in the next couple slides. So these 6 words come up all the time in package installation. And rather than let them trip you up like they tripped me up, I'm going to tell you that they do not matter, especially these first 4. If you want a highly technical description, you can definitely Google them. There's a lot of blog posts on them. I'm just going to give you a high-level description so you have some basic familiarity. Wheels and eggs are package formats, kind of like zip files. Wheels are generally preferred these days because they're easier to make Python 2 and 3 compatible. But either are usable, and as a person installing the package, will never really have to worry about this. Then we have setup tools and distutils, which are ways to distribute the packages on PyPy. So they carry this installation script that can get information from the egg or wheel file. Setup tools does everything distutils does and then some. In fact, the second paragraph of the documentation on distutils all but tells you to use setup tools and then proceeds to list the benefits of setup tools. So that's kind of ridiculous, but again, you don't really have to worry about these as the person installing the package. The only time you do kind of have a choice and you can pick which one you want is between pip and easy install, which are command line commands that trigger these installation scripts. The most commonly referred to difference is that pip uses wheels and easy install uses eggs, but there's a lot of overlap in what they do. If you're unsure which to use, go with pip. It's much more prevalent in my experience. It works faster because it uses wheels, but the biggest thing is probably that it introduced the requirements.txt file. So this is a file you include in your Python app that just lists each package and the version of the package that your app uses. Pip makes this file really easy to generate, and the presence of this file makes it really easy to replicate development environments. So to add a bit of technical detail, here's how pip and easy install work. They both find packages and generate data from setup tools. They'll install those packages using the setup.py file, and they'll include any dependencies in that installation. Finally, they'll resolve conflicts between the packages being installed and the ones already on your system. And it's here at this third step where the main difference comes in how they function. So pip will do this by uninstalling any pre-existing packages that don't match the requirements, while easy install will actually allow for different versions of a specific package on a single environment. And it can do this because it can modify sys.path. And to try to demystify what that even means, sys is a Python module that sets up system-specific variables, and it has this property called path, which is a list of strings that tells the file path to the desired module. So what Uninstall does is it takes the path to the egg file and appends that to the front of sys.path, so that when Python looks to sys.path for which module to import, it'll find this one first. So now that you know you can ignore these 4 words, you can hopefully claw your way through documentation a little bit easier, knowing that they don't really matter. And now that you know how to use pip, once you get comfortable, you might be able to switch it out for a different package installer. Like I know, for example, Anaconda is really popular in the data world. But it's really whatever's best for you, but to start, use pip. And if you run into any issues, you can Google install whatever package with pip. So if you study package installation, one thing you'll learn is that version management of packages on a system is a tricky problem to solve. A lot of the packages on PyPy are actively maintained, so they release new versions over time, and sometimes these versions are backwards compatible, but sometimes they're not. And there's a lot of ways that can mess you up, but here's a straightforward, simple example of how. So you have your operating system, and on it you want to build an application that will help you rank the New York City subway trains in terms of how smelly they are. And so in building this application, you find this package called SQL Alchemy, which allows you to perform advanced operations on data in your database. And it has this great order by method that allows you to specify the column you want to sort and the rule by which you want to sort it. So you use that, this app works great, on to the next. You create a second application where you have a person and you want to find out if they're a customer. But if they're not a customer, you don't want your application to blow up. So you find this one or none method, which will return none if no results are found. In order to use this, you have to upgrade to SQL Alchemy 1.1, because this is when one or none was introduced. So you do that, and your second app works great. But then you go back to run your first app, and you find that it no longer works, because the order by method was deprecated in SQL Alchemy 1.1, and that is the version that this application is now trying to run on. So it doesn't work. A really common solution here is virtual environments. Virtual environments allow for the installation of different versions of a package across one system. They keep these packages isolated from one another so that different apps that require different versions of a package can still work. Some people prefer not to use virtual environments, and that's totally fine. If you're comfortable and you know what you're doing, like absolutely, more power to you. But if you don't know what you're doing or you're lazy, this is a really relatively easy to use solution to this problem. When it comes to virtual environments in Python, the 2 main contenders are virtualenv and venv. If you're going to use one, use virtualenv, because it works for both Python 2 and 3, and it has a lot of really well-written documentation and blog posts out there about it. It's a package on PyPy, so you can install it with pip. Venv, on the other hand, is a library that's built into Python 3. And it actually functions pretty much identically to virtualenv, just has some different commands. So for example, here's the creation command for virtualenv, and here's the creation command for venv. But they're pretty much doing the same thing. They're saying, hey, I want to create this virtual environment, and here's where I want to do that. So they specify the path or the folder in which you want to store the virtual environment. Usually, this is the same parent folder as your application. So for example, if you want to build an app called Pizza App, which is actually something I tried to build once, you would do this by pointing the activation script to parent folder. And you could do this either by specifying the path where it would live or by running the command from inside that folder. Either way, that's where your virtualenv ends up living. And putting it here is only a recommendation, but it's a pretty good recommendation, especially for beginners, because it's a good way to stay organized. But also, a lot of the documentation assumes that you're going to do this, so it's easier to follow if that's what you do. So a virtual environment is basically just a folder with all your things, all your packages in it, plus a bash script, which modifies system variables. On creation, it makes a replica of your system Python, or whatever version you specify. But either way, you end up with a virtual environment that has its own Python interpreter tailored to the packages and Python in that virtual environment. So when your code runs, it's compiled using that environment's Python. What this means is that any application can point to any virtual environment and try to run using that Python and those packages. It won't necessarily work, but this is a great way to test whether your application will work with multiple versions of Python or multiple versions of packages. And you might be wondering, how can an app switch between virtual environments? How would it know which one to point to? And the answer lies in that bash script that I mentioned. So to run a virtual environment, you have to activate it, which means you run its activation script. This lives in the bin folder of your virtual environment, and what it does is it modifies your path variable. This is a system-level variable that tells the set of directories in which executables live. So it tells Python where to find the binary files for packages. And similar to the sys.path modification, it prepends the path to the virtual environments to the beginning of this variable. So before I run my activation script, my path variable might look like this, the output, then I'll run it. And as you can see, the path to the virtual environment is now at the front of the path variable. When you're done working and want to shut things down for the time being, you just run deactivate, and this does the opposite. It removes that path from the path variable. And if you run into any trouble while you're going through all this, you can just Google setup virtual env, and that will return some helpful results. So now we have these two covered, and here's what your setup's looking like. You have your operating system, and on that you have your virtual env with its own separate version of Python and some packages installed using pip. But there are a lot of other ingredients you need to build an application, so let's talk about those. One important architectural decision for any app is how to store data. And you don't necessarily need a database to do this. You could do something as simple as storing data in a JSON file that you keep in your application. You could do cloud storage, which requires some setup, but usually not as complex of a setup as a database. But because we don't have much time and because databases are everywhere, I'm going to cover the tried and true super common databases that you're likely to come across in Python. They are SQLite, PostgreSQL, and MySQL. SQLite is what you choose if you're working on a pet project or an application prototype. It stores the entire database in a single file on disk, which means that the database lives inside your computer. It's included in Python 2.7 on, so no extra packages are required to make it run, make it work with your app. And it's best for small applications for many reasons, but the main one is that it doesn't scale well. It only supports a single connection. It doesn't allow for sharding when your rows get too big, and it doesn't support most advanced column types, like JSON and the like. Fortunately, it's possible to move your data from SQLite to a larger database when you are ready for production. And now, if you recall the documentation I showed at the beginning, it starts to make a little bit more sense. This is just a more technical version of everything I just said about SQLite. Like this port the code line at the end, that's just saying that you can move the data to a larger database when it comes time for production. And when you get to production, PostgreSQL and MySQL are two solid bets. They're both open sourced and super mature. On a high level, you'll use MySQL when you want something really fast, and you use PostgreSQL when you want something really reliable, maybe SQL compliant. And to add a little bit more color to that, PostgreSQL has really great data integrity, and that's in part due to the SQL compliance component. It has a robust community and third-party support around its open source community, and it allows for objective storage, so nesting and things like that. However, it has been known to lack in performance, especially in applications that are read-heavy. MySQL, on the other hand, is known to be easy to set up and work with. It has advanced security features, and it's super fast even when storing huge, huge, huge amounts of data at scale. However, simultaneous read and write operations have been known to cause reliability issues with MySQL. But again, this is your first application. You're just getting your feet wet with databases, so use SQLite. It provides a really easy, relatively easy introduction to data storage. And when you choose a method of data storage for your application, the main thing to focus on is that it fits your needs. So as a beginner, you need something that's simple and well documented. You need something that easily integrates with Python and is relatively easy to understand. And SQLite fits all of those needs. Unfortunately, I don't have time to go into cloud storage, but if you are curious about this, please feel free to reach out and I'll send you some resources. And again, when it comes time to Google something, if you need help, you can just Google setup SQLite, and that will get you the tutorials you need to get this going. So now we have data storage, and here's how your setup looks. You have your SQLite database living on your operating system, and now you'll need to connect it to your application. And you do this with configuration variables, and this next piece helps with that. This is also the last major piece we're going to cover. Web frameworks make developing an application way easier because they take care of a lot of the overhead of getting things set up. And to help you understand why they're so important, I'm going to skip ahead and tell you how your application communicates with the web. So this might be a review for a lot of you, but your web communicates with your app through an HTTP request. The request will tell your app what information the user wants, and your app will retrieve that info and return it packaged as an HTTP response. But you might wonder how the request gets there and where the response goes afterwards. And in order to explain that, I'm going to tell you as simply as possible how HTTP works. So to start, you have a URL in your browser. Your browser needs to send that URL to your application. In order to do this, it needs to find the servers that host that app, and it can only find them if it has their IP address. So to get that IP address, DNS has to happen. And what DNS does is the browser sends the URL as a request via a resolver to the top-level domain server, so .com, .org, etc. So the TLD server directs the resolver to the site's name servers, and the name servers hold the IP of the app servers and map to them. So they send that IP back to the browser, and now it sends the URL to those servers via an HTTP request. The server receives the URL and sends it to the web app, and that's where the HTTP interaction that I just described happens. Your app executes the appropriate code and returns the output with a bunch of information, and the server will take that output and return it as a response under a bunch of HTTP headers. This request-response interaction is what happens under WSGI, which is the Web Server Gateway Interface. This is just a protocol made to simplify communications over HTTP that I just described. It's the point at which the web interacts with your application. So it's where the web passes the request to the application and where the application passes the response back to the web. If you want to know the gnarly details about WSGI, check out PEP 333, which is the specification in which WSGI was formalized. So with that, back to frameworks. Again, they take care of the really tedious parts of the application configuration so that you don't have to. And this includes all that HTTP WSGI business I just mentioned. You can install a framework like you would a package, and it will provide you with configuration files as well as a skeleton file structure that you can use as the basis of your application code. I'm by no means saying that you have to use a web framework. Plenty of people don't. But if you're a beginner and you don't know the intricacies of getting an app up and running, using a web framework can really help. Not only because it will do a lot of it for you, but by working with it and looking at how it does things, you can kind of get an idea of how it all works and maybe learn something for if you ever want to try to do so yourself. Experienced coders use frameworks a lot too because, again, they make your life so much easier. There are a lot of frameworks out there. I'm sure you've heard of plenty this whole conference, but I'm going to go ahead and recommend Flask for beginners because it's simple enough for a beginner to use, but it still has enough structure that you can learn from observing it and working with it. This is the point of WSGI for Flask. This is how it looks in a very basic form. And I'm going to use this WSGI point to demo some of the main functions of a web framework. So frameworks provide an easy way to specify how to match a URL from a browser to the code in your application. So here I have a defined route that will make sure this HTML is rendered if you go to my site/PyCon. And this wrapper and function are all pre-baked into the framework, so I don't have to worry about what they're doing. I just know that if I type that out, it will define that route for me. Frameworks also convert incoming HTTP requests to Python objects so that your code can more easily access key information about the request. Similarly, on the way back out, it will package the information into an HTTP response that the browser can read. Then there are template engines, and they kind of have two purposes. First, it will ensure that your app can render HTML files. So here we have the render template function, which takes care of rendering this HTML file. And this is pretty much just the same as what you see here in the return, only it's pre-baked into a file. And thanks to this Flask render template function, it knows that it can render this. With template engines, you can also pass Python data and variables directly into your HTML like you would a function, rather than having to parse an HTML string or something gross like that. Finally, they provide the ability to spin up a development web server so that you can test your changes locally. And sometimes the documentation on how to do this is unclear, but typically it involves either running a file directly from your command line or some custom command that you can find, that I guess you'll have to find in the documentation. Flask requires you to run a file directly from the command line, so that app.py is the WSGI file that I showed before, and you can see in the output it tells you the exact host and port that you can type into, or the exact IP import that you can type into your browser to get to your changes on localhost. The last thing about frameworks that I'll mention, just in case you're curious, is that web frameworks set up a skeleton file structure for you. Django and Flask are two popular ones, so here's how they do it. As you can see, Django kind of has its configuration files in a separate folder alongside the app code, while Flask has them kind of living out in the open, but still in the parent folder. But it really doesn't matter. You can do it either way. I mean, it just matters that the file path configuration variables are set up properly. But again, as a beginner, if you use Flask, you should be good. And there are so many Flask tutorials out there that if you type this into Google, you'll get a ton of helpful information. When it comes time to pick your own framework and forming your own recipe, you just need to consider that it suits the need of your application and it makes your life easier. And if you look at the 4 key purposes of a web framework that I just described, that can help you make that decision if you consider whether and how well they do these things. So once you get the framework set up, this is how your situation looks, but you have all these components and none of them are connected. So let's talk about how to do that. The main file for application configuration is usually called either settings.py or config.py. Among other things, this file will define database variables. So it will tell you the location of your database, either the IP of the server it's running on or the file path to the SQLite on your disk. This file can also indicate the host name for the server you deploy to in each environment, as well as credentials of and location of any other external integrations like Twitter or S3. Then we have requirements.txt, which you might remember. Any server that runs your application will know which versions of packages to download thanks to the presence of this file. And once they're installed, the path variable on that server will tell them where to find the executables for those packages. This is a file you might recognize, the init.py file. It's kind of everywhere. But all it does is, it's usually just an empty file, and all it does is just tell your Python compiler, like, hey, these other files that are in this folder I'm in, these are Python files, so make sure you include them when you compile all this code. And finally, we have, if you want to see WSGI, you can look for the if name equals main statement. And the file that contains this usually won't explicitly mention WSGI, but it will tell you where the web server's request, or this file is where the web server's request first makes contact with your application code. And you can kind of see how everything executes from there. So we've covered it all and hopefully demystified these different topics for you. Here's how your setup looks. And if you need help getting here, you can just Google what I did at the beginning, build and deploy a Python website using Flask and SQLite. But again, this is one of the many, many possible setups. You can sub in any technology for any one of these. You can remove some of these. You can add stuff. There's a ton of different ways to do this. It's really just a matter of preference and what makes sense to you. But if you need somewhere to start, here's what I suggest. When you want to build a web app, you'll need a virtual environment. And if you're a beginner, I recommend virtual env. When you want to set up data storage, if you're a beginner, I recommend using SQLite. And finally, for a web framework, Flask is really easy to use, and you can learn a lot from using it. And again, use pip to install any packages that you need. So now that you have this sample recipe, you can get comfortable with it. And once you're comfortable, again, you can sub out any of these for your own ingredients. And hopefully you can use what you've learned from this talk, as well as your own experience, to figure out which ingredients will work best for you and your application. So now that these steps and terms have been unmasked and demystified, hopefully you'll be better prepared to navigate the overwhelming amount of unhelpful information out there and to better understand helpful information when you come across it. And remember, knowing what to Google is half the battle. Thank you.
Excellent.
Thank you.
Stay right here. Let's give Mary one more big hand. Right on. And she's offered to take questions in the hallway track. So anybody wants to talk with her right after this, please feel free to meet with Mary in the hallway right outside?
Yeah.
Right outside. That's great. We're going to have a 10-minute break now. Thank you all so very much.